and I can't seem to find how to save last week's Jupyter notebook. So if you have it remotely in Binder, then you should be able to download it, Romeo. If it's locally on Anaconda, you should just type Control Save, and it will save it in the directory you're working in. Okay, guys. Let's start the second lecture of the Python for Beginners lecture series. Today we'll concentrate on user input, loops, and lists. So a short recap what we did last time was printing, so the print statement, if you remember, and variables, so assigning to variables, types of variables, so strings, ints, floats, and booleans, as well as operations on those. Yeah. Okay. So just a short recap how we will be working today. So there are two options. First one is that you have an Anaconda, and you will open the file in Jupyter Notebooks that I send you on the chat. You should scroll up the chat, and there's session 2 workspace, IP and B. And please open it using Anaconda. So you will just go to your Anaconda navigator, then launch it. Yep. And when you launch it, you should go to the directory in which you saved the file. So it might be your desktop or anything. In my case, it will be Python 101 workspaces, and then session 2 workspace, which is already open over here. All right. And if you want to save something in here, you just type Control S or Command S, and it should be able to save it. Otherwise, there is File, Save As, or this Save button here. And the other option is to use the binder, but I was trying to use it today and it didn't work on my machine. But basically, you go to my GitHub. I'll send you the link now. So you go to my GitHub, and then in the README, in the description here, you just click Launch Binder, and it should launch the repository. Today it was taking ages, so I would strongly recommend using Anaconda. Yeah, but if this is your only option, then I'll be slow in the beginning so you can catch up if you're using Binder. All right. Okay. So first thing we're going to consider today is user input. Well, last time we were printing things, so the computer was outputting stuff, variables, data to us. And now we can actually modify what it will print out based on what we will put in. Input in Python is a really simple thing to manage because you just use the input function, and it will save your input into the variable, which the input function outputs to. Okay. We'll do some practice in a minute in the Jupyter notebook. Okay. So for example, I have a variable name, and I'll accept it as an input. And we'll just print this name. Remember, to run a cell in Jupyter Notebooks, you just press Shift Enter. Okay. So now this cell, this white box, well, tells us to input something. Let's input Wukash. Yep. So first one is just what's left over with the input, but the actual print statement is the second execution of print. We can check it by just a separation here. So let's say Anna, right? We can do something like hi, and then the name. Right? And it will do hi Anna. Yeah, that's one version of using it. Also, the input function accepts a string parameter. So you can, let's say, tell the user to input a number. Yep. Then you can print twice the number, right? Let's say we want to do 10. You see, something really strange happened here, didn't it? So we have 10, 10. If you remember string concatenation from last time, we are able to add strings, right? Which means like connecting them. So in this case, I've written 10 and it connected 10 to 10. You can sort of multiply strings, which is like concatenating them multiple times. And this is how it looks like. But this is surely not the thing we meant with the number here. Let's say we want to add 2 to x. We have a type error. So something went wrong over here. This will be left as an exercise in a minute for you to figure out how we can fix that. There's something wrong with the types. So you can see that 2 is a number and x is a text number, so a string. We'll need to do some conversion over here. Okay. So these are some exercises for user input. It's a really short topic. So if you can type on the chat the possible fix over here, or just tackle it on your own and see how it works, I'll give you a minute.
Hi, sorry, can I just ask a quick question?
Sure.
So are we supposed to be doing our own like work in a workspace too, for like session 2 workspace as well?
Sure.
Like how
Yeah.
you're
It's
doing
for
it?
you. It's your own
Okay.
copy. Yeah.
And then when
You
we
can.
save it to our directory, right?
Yeah, you save it on your local directory unless you're working in Binder. Binder is just like you're working on some remote server far away. So
Okay.
you have to download it at the end
Okay,
of your
so
work.
I accessed session 2 workspace from your binder where it said like readme and stuff. So
Mm-hmm.
that shouldn't that I can save whatever I open from your binder to my directory, right?
So in Binder, you have to like download it to your local workspace if you want to save it, because otherwise it won't be saved.
I see. Yes.
But the
Okay,
Binder
okay.
works on your machine. That's superb. But just remember to download it if you want to have it saved afterwards.
Okay, I have to download it. Okay. All right, yeah, I see the download button. Yeah, makes sense. Cool.
Okay. Okay, there are some fixes. Okay, let's give it a shot. So you want to do int here. This is fair, and this is actually correct. what I was thinking about was putting an int here, but these are equally valid solutions. So you can use whichever you prefer. Sure. And yeah, the same problem in exercise number 2 is basically here. So we're pretty much done with that. So name equals input. Right. And then you just do this. Great. Okay. Coming back to the slides. So if there are any questions about the user input, I'm happy to answer. But it's not a difficult topic at all. You basically just assign variable, and it will always be a string. Oh, so okay. So I can see on the chat that the cells get ages to execute. This is actually the drawback of Binder. So it's like on a remote machine, so it might take a while to execute. So you can either reload your notebook or try the Anaconda environment. Otherwise, you're not using Binder, and it still take. Oh, did you actually input? Did you get a cell to input your name? Seb?
No, it didn't work.
So one thing you can do is you can stop the execution of the cell by clicking the square here, and then try to rerun it by Shift Enter, and you should get a prompt asking you to.
There you go. Now it's working.
Enter.
Thank you.
Okay. Sure. Let's continue to control flow. So control flow allows us to actually choose which statements in our code we would like to execute. It's kind of a theoretical statement, but it basically limits itself to ifs and else. So if takes in a Boolean variable. So if you remember, Booleans are either take the value of true or false. So if something is true, then we execute this code. So in this example, we take in the value given by the user, and we assign this value to the x variable. And if this x variable is greater than 10, then we will print a message informing the user that it is greater than 10. Otherwise, the print statement wouldn't be executed. So it allows us to enter. We did Petra. Don't worry, it will be in a minute on the screen if you want to have a recap. Okay. So apart from the if statement in control flow, we also have elif, which is a shortcut for else if. So if a number is smaller than 10, it will output that it is smaller than 10 with the print message. So remember not to write else if, but elif. Okay. And there is the final third statement, which is else. It takes all that is left. So if the number wasn't either greater than 10 or smaller than 10, then it's equal to 10. So it will just print out that it is 10 indeed. Yeah, let's go to exercises. So let's imagine that we want to, let's say, accept the user input. Let's say you want to complete this word, right? Now we'll check, remember double equals, that our string is equal to the cache word. So we'll have will cache. And we'll say that, yay, this is correct. You see? So I did if cache, then it's correct. What if we'll put something else? Then it won't print the yay message. What if we will do something like this? So let's first do cache, and it will print both of the messages because this code is no longer under the if statement. So you can see that if covers the things that are indented, right? So not cool will be printed no matter what's the condition on X. But what if we do this and then indent it here? You see, it just prints yay, because now our execution kind of has two different branches to go into. If the X is equal to cache, you indent with a tab. If the input is equal to cache, then we'll print yay. Else we'll just print that something is not cool. All right. How about we do else if, which is elif, and we can have some other condition. Let's say $. And we can print, let's say, rich. Okay, so if I put $, here, then it will print rich. If I put cache in here, then it will print yay. So the way it is executed goes from the first if. So if it accepts the first possible condition, it will just execute it, and then it will go to the end. You can see the difference between the two if you do 2 times if, right? Let's say we have a 2 ifs for the $. It goes like this. Now I put in $, and it prints both of them because the program goes from the top, so it goes here, sees that the X is indeed $, so it's accepted, right? It goes into help, but then again there is another if, like construction, that allows us to call $, again. That is why we'll get rich here. We can also have multiple elifs, which are kind of in the same group. This is a separate group of if from this one. Okay, so now let's try with this one, red, and it will indeed print blue. Okay, so important things to remember here is that if is always first, then it can be followed by some elifs, and finally there is the else statement that takes everything else. But there can also be statements that are outside this if construction, so this will be always printed. Okay. So now let's tackle some exercises. If you have some questions, please put them in the chat, and I'll give you a couple of minutes to do question number 1, and then we'll try to tackle question number 2. For question number 2, you might actually have to Google something, like, let's say, string string functions Python, but I'll do it anyway in 5 minutes, in like 2 minutes. So yeah, either shout out on the call that you've done question number 1, or just put it in the chat. I can see the question from Petra from a couple of minutes ago. We did question number 2, exercise number 2. It was just basically name input, and then we print the name. Yep. Okay, I'll start with exercise number 1. Okay, so if we input Polo, then it will, oh, sorry, Polo. Oh, you see? So my thing just got bugged, so I just terminate the execution and I try again. Okay. So yeah, Marco Polo. Otherwise, Marco Disco doesn't work. Okay. So for question number 2, we actually have to use some knowledge that wasn't on the lectures initially, but let's try it. So we will first accept the user input. And now we have to turn it into some form that will always be the same no matter what the capitalization of letters was. So the way we usually do it when we don't know the function, we type something like string. Right? And then we'll go to like W3 schools. And we can search for something like to upper or upper. Right? There is an upper function, for example. So upper function will turn a string to uppercase, and then we can basically copy this code. But now we'll have to make sure that we check for uppercase input. Okay, it doesn't work apparently. Oh, that's strange. Do you have a working solution, guys, here? Okay. Let's try lower. It goes to lower. Oh, right, sorry, because it's X, you see. Okay. We should do X here. Okay, and now we can input any capitalization of the string, and it will work. All right. Any questions about the control flow exercises or statements?
Could you quickly show us the code for the last one again? Thank you.
Sure. Here it is. So the only difference with the first one is that you do X lower here, or polo lower. Depends what was the name of your input variable.
Mine was just X.
Yeah, here it's just X. So Petra, yes, this is actually, I think you can, so first, Ahmad, I think it's perfectly reasonable to do it, but let's check. We'll put it in a comment here. Remember commenting with hashtag. Yeah, it works. So you can do lower straight away in the input. Petra, does it matter? It only matters whether you check if this string is only in uppercase or lowercase. So if you go upper, then this string should be in uppercase. Otherwise, it should be in lowercase if you go to lower. We decided to go lower. But it's up to the person. Let's also check if it is correctly. We don't input polo. Yeah, it does go away. Cool. All right, on to some more exciting stuff where actually we can see the speed of computers leveraging things. So we had this function Marco Polo, right? And Now we are using just the control flow to yay or incorrect. But what if we want to keep on playing if we put in polo constantly? So it will just ask us for Marco, and if we will put in polo, then it will always say Marco. Okay. So we'll use the while loop. So while loop has some initial condition that it will make the program execute unless this condition is not satisfied, or we will break out of the while loop. Okay, let's see how it works. It's already in the exercises, so we'll go straight to it. So we'll for sure need a while statement. But also we'll need the input. We'll use here. Right? And if polo equals to polo, then we'll keep on playing. So we'll just do this. And also we'll do some control flow here with the same function as previously. Remember to use tabs correctly. Okay. And every time we'll execute this while loop, so it will kind of go on until it's not polo, we'll update the polo variable. So let's see how it works. I'll put in polo. Okay, polo. Okay, polo. Alco, say. And it stops, right? It terminates because the program did check the condition, whether polo is equal to polo, and it's not. It's equal to alco, so it terminates. Okay. What if we didn't have this statement? I don't know why it's go away, but why does it go away? Okay. You can see that it constantly prints go away. So it's in the infinite loop state. So it will keep on printing, and you can see the star here. It's still executing. Okay, I've terminated it, and we'll see the correct version again. There's something deeply wrong. Oh yeah, because it's X. I always forget it. Okay. Polo, polo, polo. Right, and if not, then it stops. Otherwise, if we don't update it, and we'll put in polo at the beginning, then it will do yay until it basically dies. So we'll have to terminate it. This is called an infinite loop, and this is quite a common occurrence in computing, in computer science. So we just didn't take into account that the condition might be always true. So if polo is polo, then this basically evaluates to while true. and this is an infinite loop. There is also another way to actually save this. So if it's not Polo, then we will enter the else statement, right? We'll enter the else statement, and by entering it, we'll know that it is no longer Polo, so we can do the break statement. Right? And break statement basically breaks the loop. It breaks out of the while statement. You see? I went with Polo, it's not updated, right? We actually have to ask for this again. Right? And if it's not, then it will print go away and then break. All right. Let's try to tackle the second question, which is the Fibonacci numbers question. So one short hint is that you have to keep track of the last two Fibonacci numbers. So and you'll have to update those in your while loop. And yeah, when you reach the Fibonacci number that is greater than 50, then your while loop should terminate. All right, if you have any questions, guys, I try to follow the chat, but I can see the Seth's question. What is the question?
What's wrong with my code? If I put literally if I input anything into the text box, it prints something nice, so the positive result.
Is it indented correctly? And also, yeah, you do the same. You do the same thing as I did. Sorry, guys. Polo. So the last line you update Polo. You don't update X.
Oh, it's meant to be X.
Yeah. Yeah, it should be.
Now I need to stop the cell. So okay, there you go. Now it's working. Thank you.
Sorry, can I ask a quick
Any other
question as well?
questions?
Yeah. How does the program know when while ends? Because you can still carry on writing down, but there's no clear indication in my eyes for when the while loop ends. I mean, I get it. Like if the argument is not what you wrote, I should know that kind of makes sense actually.
So
I mean, in the end, you
checks the
wrote Polo,
condition
yeah.
every time it comes back here, right? So it runs the indented code and then goes up. And break statement is basically a key statement. It's translated straight away to get out of the while loop.
Okay.
Okay. Anything else? Okay, let's try the Fibonacci question. Your code doesn't work. Okay, Ming. What's wrong with your code? You can unmute yourself, Ming, if you want to, and we can just discuss it for a minute. Yeah, okay. Vincent will try to help you, and I'll continue with the Fibonacci sequence question. Okay, so we'll be checking on the let's say we'll have F2 variable, which is equal to 0 for now. We'll be checking whether the F2 variable is smaller than 50. Okay, and F2 will be equal to F1 plus F0. You can actually do it like F1 plus F0. Okay, and we also need to update the other variables. I think, yes, sorry guys, this might be a bit confusing. Okay, so we'll keep in track of the two variables. Okie dokie. Now F1 is equal to F2, and F0 is equal to F R. Okay. And this should work. Yeah, it actually, yeah. If you don't want to print 55, then you can do the printing here, I think. Yep. So this program basically tracks the numbers. So this allows us to print the first couple of Fibonacci sequence terms by repetition and updating those variables. Okay. On to the third exercise. I'll keep the code for the second one here, so you can think about it while I'll do the third exercise. So we will want to print temperature from 20 Fahrenheit to 85 Fahrenheit, right? So while temperature is smaller or equal to 80, we'll keep on running the while loop. We'll print 5/9 times t minus 32, and then we'll increment the temperature by 5, as they say in the spec here, 5 Fahrenheit increments. And let's see how it goes. Okay. So these are the Fahrenheit. These are the Celsius values of the Fahrenheit from 20 to 80. If you want to go to 85, then you just change it here. Otherwise 80. We need to remember about incrementing, which means that increasing the value of t by 5 every time we go through the while loop, because otherwise we would again have an infinite loop. You see? And it gets stuck. So we need to terminate it here and then run it again. Okay, does anyone want to see the code from the previous exercises? Or are there any questions to the code? We'll be coming back to the presentation now. There is actually a very interesting fact that Vincent and Ming found out. If you have the polo equals polo here, right? And if you input something else at the beginning, it won't do anything because it also checks on the entrance whether the condition is true. All right. Coming back to the slides. Oh, yeah, sure. We'll just do the while true once again. So while true just basically it will run forever unless we break out of it. So this break statement kind of exits the while. If we wouldn't have it, so if it would always keep on going, no matter what we enter, because there is no condition being checked. We just say, run it until you see the break statement. And if there would be no break statement, then it will keep on going. Does it answer your question, Miguel? Great. You see? So, as I said, we have while true, and this will keep on forever because there is no break statement. Yeah. This is another way of writing this function. Okay, we'll now continue into lists, which are the first data structures we will tackle in Python. These are probably the most appealing ones and the ones that you might find most familiar. So list is basically a collection of objects. It is all, and it can have objects of different types. So for example, here we have a list of 4 numbers, 1, 2, 3, and 4. We can print the list, and it has some nice printing format. You can try it in your notebook. And we can append to the list. Appending to the list means adding something to the end of the list, which means adding behind this bracket, and it will expand the list. All right. Also, we can start with an empty list. This is how we just signify that Y will be a list. And then we can append to it to expand it. So here, Y will already have the element 1 inside it. So you can try this code now and let me know in the chat. What does it print out? It might be unexpected for some of you. Anyone trying the code on the machine? Yep, thanks, Ahmed. So it prints out number 4, not number 3. So lists are actually indexed, which means the first element which we can access is element number 0. So we start from number 0. So in this case, if we would do mylist 0, we would get number 1. So kind of the first element of the list is indexed by 0. Second element is indexed by 1. This is kind of counterintuitive. Okay, sorry for that. Right. Anyone wants to try this one? Please put it on the chat then. Sure. Nice, May. So negative numbers are actually traversing the list from the back. But to make things a little bit more complicated, when we index from the back, we index from 1. So the first element from the back of the list, it's -1 element. You can kind of think about it that the 0th element is already like occupied. So to index from the back, we have to start from -1. So we use -1. Okay. Cool. You can now try this one and let me know what it prints out. I will highly appreciate if many people will give it a shot. It's the way we learn. Okay. And output. Thanks, Harvey. So, yeah, the length of the list, which you might probably figure out, is 5. So it is the number of elements in the list. Cool. So let's give a list some practice. Okay, we'll make a field here. So we'll create my list, which is, let's start indexing from 0 then. And now we'll print the 0th element, which is 0. Let's print the third element, say, which is actually the element number 4. Okay, apart from that, let's print the -2 element, which is the second one from the back of the list. Great. And now let's do something more interesting. So we know how to retrieve elements of the list. How about we try How about we try retrieving sublists of a list? So to actually do it, let's say we want to retrieve elements of my list from indices up to the second index, let's say. You see, now it prints a list. So we go from the 0th and first index, and these are the indices that are smaller than 2. Okay. Let's say we want to print elements that are bigger than the third index. It prints 3, 4, 5. So number on the left is inclusive. So we will get the third index included up to the end of the list. If we want to give clear borders on which subset of the list we want to print, we can go from the second index to index number 5. Right? So it doesn't print the last element, number 5, because it's not included. Okay. Let's say we want to print the elements on the, let's say, even indices, right? So on index number 2, on index number 4, index number 6. Then we'll do 2 columns. So this is the starting index in the first space here, then the ending index. If they are empty, then we're printing the whole list, right? And after this third column, we can specify the amount of jumping we do. So if we will do 1, then it will just print the whole list, right? But if we'll do 2, it will print only the even elements of the list. Okay. Now guys, tell me, how can I print the list in reverse using this colon notation? What would be the third number here? Give it a shot on the chat. Exactly. -1. This reverses the list. This is actually one of the more useful features in Python, that you can reverse a list so fast. And if we want to get the elements in reverse, but every second element, we do -2. This is quite handy. Okay, how about we also want to append something to our list? Do append, and then in the bracket we will do, let's say, append 9, right? And then we'll print our list after the append operation. You see, 9 was appended to our initial list. There is also an operation that counters the effect of append. It's called pop. This removes the last element of the list. You see? Also, pop actually returns the element that it popped, it removed. So it can be assigned to a variable. You see? Now x is a 9. This pop comes from a data structure called stack, which we'll cover in the last lecture. Okay, these are some basic operations on list. Here are a couple of questions we can tackle. Let's consider the first question. So, are there any constraints on what can be in the lists? Lists in Python are actually very, very flexible. So let's do a list L. It can have multiple types inside it, and it won't shout at you. So here are the types we learned on the last lesson, and this list can have all of them, and Python won't throw an error. This is actually a feature that is not very common in other languages. In other languages, if you continue and study other languages, you can have lists only of one certain type. So for example, of Boolean or of integers. But here we can have all of them, all of the types. So let's say we want to print the 1 or print the focus string. Okay. Let's say we want to compare two lists. So first we will want to copy them. So let's make a list K, which will be the list L. This is how we copy lists. Why do we copy lists, not just assign the same variable to it? So it actually has a very unpleasant side effect, which I sometimes get caught into. So if I do now K append, let's say 5, and then I print K, and then I print L, you might get an unexpected output here. So you see these lists are still the same, even though I appended only to K. So this is the time when we have to think a little bit about objects. So L is an object. So it is some space in memory. Let's go back to the slides. It's quite nicely explained in the slides. A minute. Oh, you see, we have list number 1. And then we have list number 2. This is somewhere in memory, as we can see on the slide. So 1, 2, 3, 4, 5 is somewhere in memory, and these two variables correspond to the same list object. Object, which is basically some small space in memory. If we will do the appending, it will modify them both, right? We can check whether two lists are actually the same by calling the ID function. Okay. Let's give it a shot then. So now, to copy a list, we'll just have to take it all, right? So we do our square brackets and a colon inside, and it copies the list. Let's see if the equals operation works on the lists. Okay, this is true. And this is true as well. But let's say we want to compare their IDs. You see, they have different IDs because K is a copy. So it means that K now occupies a different space in memory. If we would just do K equals L, then it would be true. Now you might ask, why does this work, even though they have different IDs? The answer is, I don't really remember because you hardly ever compare the lists this way, but Python is quite smart, so it probably just compares the two objects element-wise. The way I would do it is using a loop, but a different kind of loop than a while loop, which we'll learn in a couple of minutes. Okay, but for the safety sake, just copy the lists, because you can modify them with different variables and get some unwanted effects quite often.
A good question in the chat is, does the equals equals operator compare contents or ID?
So as we have seen, it does compare the contents, but if you explicitly call the ID function, you will get a false. So we can do this operation will return true because they have the same contents. Let's say we will append 3. Now it's false because L is modified but K is not. Coming back to the normal version. So they are compared content-wise. But if you now compare IDs, they are different objects. So it's false. Okay, let's just append something to K. We'll append 3. And then compare them again with the comparison in the first sense, so not the IDs but the objects themselves, then we'll get a false, right? Because we changed K, but we did it safely, so we didn't change L. This is kind of a bit hard to digest, so if you have any questions, please type them in the chat now or shout out on the lecture. I'm happy to answer. Okay, I don't see anything now. Yeah, it takes a while to process. Maybe in the chat if you want me to reiterate it or repeat it again, or if it's fine. Sure. Okay. Let's come back to the slides because I think they're excellent. Because I haven't done them, my friend did them. So it's even better. Okay. So first we create a list which points to some space in memory. Memory, which is an actual physical silicon space in your laptop, right? A space in RAM, probably. Now we create another one, list 2, and we just assign list 1 to it. Okay? It still points to the same physical memory. Both of those objects point to the same physical memory. So if we'll append or modify the list in any way, then we will modify both of them because they point to the same physical space. The way we tackle this problem is by copying, which is here. K equals L square brackets colon square brackets. Because this copies a list, so creates a separate space for K in the memory, and now they point to 2 different spaces in the memory. Okay. Another way to compare IDs is actually by doing K is L. Is calls the ID operator, usually. Okay. Right. Let's try some arithmetic operations. Okay, we'll do some comment here. Okay. Let's now consider arithmetic. Yes?
So you know where you wrote K is equal to L bracket semicolon close bracket?
Yeah.
If you didn't write the bracket bracket semicolon close bracket, if you didn't write that, with the operation you're doing afterwards, like K, the comparisons and checking the IDs, would that still all be valid?
So you're asking about if I won't do the square bracket, colon, square bracket, right?
Yeah, if you remove that, like with the operations you're doing, like print.
Let's have a look with the first three operations, right?
Hmm.
Okay, I'll actually print a new line. Yeah. Okay, so now they are the same, right? So hey, they have the same contents, which is this comparison. Here, they are the same objects. These last two checks are equivalent. Okay, so this gets compiled, which gets interpreted by the computer the same way as this thing.
Okay.
So they are the same object, they are the same physical space now, in case of this assignment. So it returns all true.
Yep. But in the previous case, it was true, false, false, right?
Yeah.
Well, yeah.
Here we get false because this is a copy.
I see. One's a copy
You can
and one's a
also
direct.
do a copy method. Which works the same. But it's just a shorthand for the copy method to just get the whole list.
So the first
And it's
one,
faster.
the first one, is it a copy or
Here is a copy. Yeah.
that's a copy? But the second one is a direct.
Yeah. And here is the same object. Yep.
Okay.
Yeah, it might actually be my washing machine. I'm really sorry because I'll try to decrease the volume of my microphone a little bit. Is it better now?
It's not a big issue. It's just minor noise.
Okay. Sure.
Okay. Cool.
So no worry, Ahmad. Yeah, I shouldn't be doing that, but it's my parents basically. Anyway, you're lifting up the. Okay, wait. So what is your question, Ahmad? You want to unmute maybe because I kind of don't get what you mean. A syntax error, right? Harvey, you have wrong brackets. It should be square brackets on the first line. Okay, thanks, Ahmad. Okay. Now, let's think about arithmetic operations on list. So, as you might remember, strings are a list of characters. So the operations will be kind of similar, especially addition, which is concatenation. Let's say we have list 1, which is 1, 1, 2, 3. And let's say we have a list 2, which is 3, 4, 5. 3, 4, 5. Now we want to print L1 plus L2. You see they are concatenated, connected together. Okay. What if we subtract them? You see, you can't subtract lists. Subtraction is not allowed. Can we multiply them, perhaps? No. Division? No. So we can only add lists, which means to concatenate them. What is the other question? Okay. Final thing which we have to consider is what if we want to retrieve something that doesn't exist in a list. So let's say we have a list L1 and it has 3, 4, 5 elements inside it, right? But you want to just print the, let's say, 65th element. We get what's called an index error. So an index error is accessing something that's outside of the list. Right? It will terminate the execution of our program and it will throw an index error. You might also think about it that you're accessing the physical memory that you didn't say that you will want to access. Say, it throws an error. Right? Usually a good check for those things is to check whether an index is smaller than the length of the list. And yeah, that's enough of a check. What if it's minus 65? Also. Okay. But if it's minus 2, then it's fine. We just get 4 because it's inside the bounds of the list. Okay. There is also a useful remove function. Let's say we have a list. But okay, are there any questions for now, or is it rather clear? Okay. I'll assume that silence is consent. Let's say we have a list with some random integers, right? And we want to remove 4 from it. You see, you can remove number 4. So actually the thing you insert in the remove is the value you want to remove, not the index. We'll have a separate function for that. So remove removes the value from the list. What if we would have 2 times 4 in the list? So 4, 4, and then other numbers. Then it removes it only once, right? So it removes only once. Therefore, we still have 1 4 left here. Okay. Let's say we have a list 6, 7, 8, and we want to remove 1, which is not in our list. Let's see what happens. Value error. So the value we wanted to remove was not in the list. Therefore, it shouts at us that it's an incorrect access. Great. There is also a delete function. We have another list. Let's say we want to remove the element. So delete it, but the element at position number 1, let's say. Invalid. Or maybe. I actually don't remember how that looks like. You see, if you don't remember something, you just type it into Google and it shows up. Okay. All right. So it works differently from what oh no. Cool. So we just use the del keyword and then we remove the element 1 from the list. Okay. You see? And it removes the element at index 1 from the list. Okay. We can actually do it again and it will remove, but a different element from the list. Okay. All right. Let's answer the third question. Because it's quite interesting. So here we can just use a while loop with some counter. So a counter is usually a variable that counts something, right? And we'll check if the counter is smaller than the length of the list, but the list we were initially given. So let's say we are given list 1, 2, 3, 4, 5. Okay. We do init len, and it's the length of the list we were initially given. And we'll keep on deleting from the list until it's empty, which will be how many operations? Len of L. So let's say we do print, and we can use the pop function, which is quite useful. So L pop. There you see, we have an index error because it's empty. So we might actually have to do -1 here. Still. Oh, all right, of course. We need to also take into account to actually increment the counter. Yep. Now it should work. Exactly. So now it removes every single element from the list and actually prints them in reverse order. If we would like to print them in the actual order, we can do del L of 0. It removes them in the actual order, but doesn't return the element, I think. We can give it a shot. No, we can't print this element. So pop gives us a bit more power here. Okay. Cool. Coming back to the slides. Cloning a list, which we did in a minute, in like a bit ago. Okay. There are also other functions which are quite useful for the lists. Invalid syntax. Sef. Yeah, because you have a 1 there, not an L. in front of pop, you should have an L, not a 1.
Thank you.
Okay. So pop we did, copy we did, insert. Insert actually inserts at an index. You can treat it as a homework to try out those functions. Reverse is a list. Sort sorts a list, so you will sort it in increasing order. And index will give us an index of a value. We can actually try it here. So let's say we want to have a function. We have a list like this, and we go index, let's say 5. Okay, it gives us the index of number 5 in this list. If we'll have okay. Okay. Sorry guys, we can use an ls here for the future reference. It's kind of hard, yeah, to distinguish. Okay. ls. So it gives us the index of the first occurrence of 5 in the list. All right. Any questions? There is an exercise here. You can treat it as a homework for you guys if you want to. I won't go through it now because we'll still have to do the for loops. Are there any questions? Okay. Let's now consider the last topic of today, which is the for loops. For loops are a different type of loops, like while loops, but they have some different structure. So we had this thing, we can imagine we want to write a program to print all the numbers from 1 up to n. Right, so the way we would approach it in a normal sense is that we would do a while loop, a counter, we would increment the counter and print the counter every time we enter the while loop. But there is a different way to do it, a bit more compact, which is using a for loop. For loop has the structure as follows. So we start with the for word, then we do I. I is the most frequent name for the variable we use in the for loop. And then this I will be in something. In this case, it will be in range. Range is another function that generates a range from 1 up to n plus 1. N plus 1 not included. And it will just increment I on every entry. We'll go into it in a second. You see. So this is why we include n plus 1 here, because range doesn't include n. And our initial question was to print all numbers from 1 up to n. Okay. Let's go to the for loop. And now we have sort of a different flavor of the same question. So let's accept an input from the user. We accept an input from the user, which is an n. And now for I in range 1 up to 3 times n plus 1, we will print all the multiples of 3. So the thing we have to do, and the thing we have to consider here, is that it is a multiple of 3. The way we can do it, for example, is to use the remainder operator, if you remember. So we recall the control flow, right? And now I, kind of remainder from division by 3, should be equal to 0. Then we're sure that I is a multiple of 3. All right, then we print I. Let's say we want 5. So it will be 3 times 5. There is a type error. Right, so I did the same mistake we did at the beginning of the lecture. We have to convert it to int, and now it prints all the multiples. All the multiples of 3 that are smaller than 15, or 3 times 5. Smaller or equal to. There's also another way of doing it. So we can start from 0 here, right? And then we can add 3 on every iteration. So this range function is mostly, yeah, that's a really good question, Harvey. So +1 is the default in for loop. So we will usually increment I by 1 because this is the default of the for loop. So we don't write it because Python sort of already knows it. But if we want to increment by some other value, then we write it as the third argument of the range function, right? So 0 is the first argument, then the final value, and then by how much we want to increment.
Sorry if I'm wrong, but I think maybe Harvey meant why do you have the +1 after the NN?
All right. Sure. We just do it because, as you remember with the lists, the last number is not included usually. So we want to go from 1 up to 3 times n. But if I would write 3 times n, or int converted to n, then it wouldn't count the last number because it's not included in the range. Cool. And it prints out the same, except that it prints out 0 as well. But we can start from 3 here, and it will print out the same thing. Okay? Also, the things that for loops usually take for granted is that if you don't put anything as the first argument, it will throw an invalid syntax. But if you don't put anything as the first argument, right, and just put the kind of the end value, it will compile successfully. So it will go from 0 over here. There will be kind of 0 here, but it's default. And it will be 1 here, also default. So this is kind of the simplest way we can define a for loop. But if you want to, you can always define the arguments here, which is actually a very good thing to do. It will work basically the same. Okay. There is also another way to use a for loop, which is to use it with lists. And it's a very common usage of for loops. So I define a list, let's say 4, 5, 6, 3, 2, 7. And I want to print every single element of the list, let's say in a separate line. So I do for I in ls. So it's not now, it is not now in the range, it's in the list. And now I print I, and it will print every single element of the list. Okay. Any questions so far regarding the for loop? No questions at all? Okay, I guess everyone is a bit tired, so let's just do the 2 exercises and we'll be done for today. Okay, so this is the same exercise as we had with the for loop. So now we'll do the temperature, so T, in range from 20 up to 80 plus 1, and we'll increment by 5, right? Okay, oh, sorry. So yeah, this is basically the solution, just 2 lines. For loop is way more compact. All right. So we start from 20, go up to 80, plus 1 because we want to include 80, and then increment by 5 on every iteration, every entrance into the loop. Okay. How about we do this question? So let's say we iterate over the range. We accept the user input n, right? And we will iterate up to n plus 1. And we want to create such a triangle, right? Let's try to print a range then. Okay, printing a range doesn't really work. How about we do a for loop inside a for loop? Okay, so we do a temporary variable, which is a string, right? And we will do a for loop, j in range. We now have to use a different name of the variable because if we would use I, it would be confusing for the compiler. So we go from 1 up to I plus 1. We append, which is plus equals this thing, plus a space to make it look nicer. And we try this one. We also need to print the temp. And we get the triangle we wanted. Right. We have 2 for loops here. They are nested loops. All right, coming back to the slides. Do you have any questions regarding this? All right. Mine isn't working. What is not working? Okay, what is the error that it prints? Amandine, what is the error that your code prints, or what doesn't work? Also, your string is not finished. Your temp is not finished. You should have two. All right, that might be confusing. You should have like a closed parentheses, right? You can use either a single paren or a double parentheses, right? You need to close it. This might be why it's not working. Yeah, you need to convert to int in the input, because remember that input returns a string, a text. Yeah, you shouldn't print the range first of all. So range is not needed here. And you should print in the first for loop, so it shouldn't be indented that much, your print. Okay, we do plus equals here because we'll want to we start from the empty string and we'll be building it up like by every iteration of the loop. Okay. If there are any other questions, then please stay after the lecture and we can talk it through. Okay, a homework which you might want to do is nested lists and list comprehensions. I'll paste a link in the chat just after the lecture where you can investigate those topics. And they are quite useful. They allow us to make the code a little shorter. All right, and yeah, that's it for today. I see you guys next week. Next week we'll be doing functions and a short recap of everything we did already in the span of last 2 weeks, because it was quite a bit, especially in this lecture. So please stay after the lecture if you have any other questions or your code isn't working. Please have Anaconda installed. It's not very hard to get it working. If you have issues, please text me on Facebook or Teams or email. And yeah, that's it for today. I hope you had fun. And yeah, I'll see you next week. Please stay a while if you have any further questions. We'll stop recording now, Vincent. And yeah, Also, great thanks to Vincent for answering some of the questions.